How many times do I have to say it? Page 40. Financial arithmetic. This is going to be the last chapter we're working on for financial math for the recursion topic. It's recording, right? We're good? Yeah, we're good. All right, cool. Now, this chapter is a bit confusing because it uses the word arithmetic. Obviously, what did we learn about arithmetic? It's adding and subtracting by the... Yeah, but in this case, it's actually not arithmetic in that regard. It's just geometric. Arithmetic actually just means basic math. Yeah, so in this sense, it's just talking about basic financial math, but we're going to apply it to compound interest. Okay, we've been learning about simple interest. It's the same as arithmetic recurrence relations. What do we learn about compound interest, guys? Is it the same as what? So if arithmetic is adding and subtracting, which is what compound interest is, it starts with G. It's a geometric sequence. So we're just working again with geometric sequences. That's all it is. It's nothing crazy. It's just multiplying by the same number. We're not using division because, again, remember, when you multiply with a number greater than 1, it goes up. And then with a number less than 1, it goes down. All right, so that's why we'll just use multiplication for this. As a learning intention, and what I want you to learn today is I want you to apply everything you learned about with geometric sequences, but now to money. Okay? And I hate this, and I also love this because I wish at your age I learned about this because I'm actually using this at this moment right now. I'm on the phone constantly with the bank about hiring a car, buying a car, and man, it's annoying. It's so expensive. Yeah, and it's actually helping me now because if you don't know about this stuff, a lot of you, I reckon, are just going to sign the paperwork and say yes, and then you won't realize how much you've paid for until the very end. Yeah, if you don't actually do the numbers properly using arithmetic or geometric sequences, a lot of the times, if you buy a house that's like, I don't know, $500,000, in the end, you end up paying all up $800,000.
Why?
Because of the interest. And because of what they charge you if you don't calculate it yourself. Okay? So you got to make sure that when you actually go and buy a house or buy a car, use the stuff that I've taught you here because that's essentially what the math is for those questions. Yeah. Anyway, so by the end of today, I want you to use everything you've learned geometric wise and apply it to our compounded investments, or if you're borrowing money, a loan. And then I want you to be able to. Everyone knows what a principal is. Yeah, what's the principal? The beninging. Good. All right. Identify the interest rate. So remember, with this year, we're only using rate per year. Okay, so it's just once a year. And we also want to look at the interest. So what's interest, guys? More, yeah, no, that's more the rate. The interest is
How much extra you pay?
extra. Good. It's whatever you're paying back or whatever you're earning. Okay, that's the interest. So let's go back to my house example. Say I bought a house for 500K, but then I did the math and I realized that I actually paid 800,000K. That's 80,000. What's the interest there?
300,000.
The interest, the extra I paid is 300,000, and that's what you call interest. I've bought a house, yes, but not now. That was before. All right, so interest is extra money that you got to pay back. And remember what a recurrence relation is? Krish, can you remind me what's a recurrence relation? Anyone remember what's a recurrence relation? There's two things it tells you. Tells you T0. What's T0? Tell me. The starts with S, the starting amount, or it could be the initial or the principal. Okay, you might see that, or it could be principal. It all means the same thing. Okay, and then what's the next thing it tells you? Tn plus 1 is equal to, it might be like Tn. And if it's geometric, what are you using? Times, good. And what are you timesing by? The common ratio. Common ratio. Come on, Attila. Square up. No, square up there. Lock in. It is on. Why isn't it different? Because common difference is add, subtract. Ratio is multiply. Okay, that's what we learned about, yeah? All right, let's use this. So, bit of an example with compound interest. So remember, with simple interest, you're just adding and subtracting. Yeah, there's a lot of words here, but I'm going to give you the short version of it. Compound interest is you're basically just multiplying by the same amount. Instead of adding, you're just multiplying. Okay, and because you're multiplying, what you'll find is when you actually graph this out and you compare it to simple, the way that the graph works is different. Yeah, so for simple interest, what kind of line are we working with? It's just straight. Yeah, it's either straight up or straight down. What happens with compound interest or geometric sequences? It's curving. Yeah, so it's slightly different in that because when you're multiplying, you'll notice that the lines are going to curve. When it comes to compound interest, okay, I'll highlight the important terms here. What you're doing, okay, is you're adding interest. So interest is calculated at the end of a compound period. Okay, and then what happens is you're just multiplying each time. That's it. So instead of adding, you're just calculating interest at the end of each one. So it's going to be slightly different. And I'll show you how that works. Let's go back to, do you guys remember the Guido example? It was like in chapter 3E, I think it was. Okay, in the Guido example, alright, when we worked with Guido and we did simple interest, let's go back to this. How do we calculate the common difference for this question here? Does anyone remember? What was the formula? Does anyone remember it? Not quite. No, it's the big common difference is percentage over something. Times by what?
Common ratio.
V0. The number. V0. So in this one here, Abby, can you tell me what are we doing here? What's the percentage rate here? Good. Times by? Good. And what does that give you? Shh. And what does that give you? The common what? Starts with the common difference. So 5 divided by 100. Okay, gives us 150. So what does this tell us, guys? No, not times. This is for simple. Yeah, you're adding each time. Yeah, with the common difference. You're adding. So when we do that, and he starts with 3,000, okay, to get the next number, you have to add 150, yeah? So it's always the same amount. You can see here. It's always 150 when it's simple interest. And here's the table again. So what they do is at the end of each rate or each term, you're just adding the same amount. Yeah, that's just simple.
Can you write that instead of the other thing?
Say that which write what?
Write the table instead of that.
No, unfortunately. A lot of the times the question is going to ask you to do this. Yeah, but sometimes you might have a table like this and you need to fill it in. Okay, shh. Chris, what happens when I graph this? Is it going to be straight or curved? Have a think, man. It's simple interest. You're adding the same amount. What do we learn about simple? It goes up and down by the same. So is it going to be straight or curved? Good. Okay, so if you were to graph it and you were to put a line, okay, your graph should give you a straight line like that. Yeah, because again, it's just adding the same amount. Okay, the same amount each time. Now, if I compare that, however, to compound interest, and we're going to fill this table in. Okay, so with compound interest, right? Well, let's fill this table in and what would happen if you actually did it with compound interest? Same rate, but just compound. So what we're going to do is we need to calculate the interest here. It's already filled in there for you, but we're going to do it anyway so we get what we're doing. So to find the interest, we're going to go 3150 times 5 over 100. And what does that give us? Anyone know? All right, put it in your calculator. 3150 times 5 over 100. Now, you don't need to learn how to do this. It's okay. But we're just going to show you. So this is 157.5. So I tell her how much money does he have in the balance after that. So if he has this much, and then you're adding this much interest, how much is in the balance? Well, just add it together. Yeah? So plus 3150. Okay, which equals 3307.5. So in the next term, you're going to start with 3307.5. And again, because this is a geometric sequence, you're not adding the same amount. Because here at the first year, they added 150, but in the second year, it's 157. It's not the same. Okay, it increased. So what you'll do now, and this is how compound interest works, get your balance again and multiply it by the interest rate. Okay, so if you repeat the process, what do you guys think is going to happen in the next year? Okay, 5 divided by 100. So now we have 165. What do we see with the interest, guys? It's going up. Why is it going up? Because why? 65. It's compound interest. It's not the same amount each year. It's multiplying this time, yeah? So in the end, when I add it together, so add that to 3.
So what is compounding? Like the actual word just in general.
It just means it's stacking up. It's compounding. It's like adding on top of what you already have. Whereas simple, it's adding the same amount, yeah? Compound builds on what happened the year before. 3472.37. Okay, do you guys see a pattern here? What's the next thing? So what do you do? What do you put in number 4 now?
3472.
Yeah, this is gonna most likely be on your sack. In the end, just write it in the end, yeah. And then in the interest, same thing. So you're gonna keep calculating the interest at the end of so at every new term. Oh yeah, I didn't put the 5 here, but that's all right. Shh, thank you. So where are we at? 3472.37 times 5 over 100. 173.62. It's 3, sorry. And then, so after 4 years, let's add that back. 3472.37. And this is depending on the rounding, yeah? So 3645.99. It might be a bit different in the other one, but 0.99. I think it's a bit different in the other one. Yeah, so because of the rounding, that's okay. So you'll notice that when we do it again here, it's different because of the rounding, but it happens when you round, but that's all right. But do you guys see what's happening each term? Can anyone explain it to me? Yeah, it's increasing by a different amount. Again, it's because why? Because it's a geometric. When you're working with geometric, because it's multiplying, okay, you're not adding the same amount anymore. You're adding by depending on the interest for the previous term. Okay, that's the difference here. Cool. So, what would happen? It's slightly different because of the rounding. So, if I was to put that in a table, this is what we have, yeah? Again, slightly different to what you have, but that's okay. This is what we have here. So, if I was to try and graph this, let's try and graph this. So, I've already graphed the previous one, which is in the blue dot, but let's graph the compound interest one. So, at 0, we've got 3,000. That's fine. At year 1, we have 3150. Okay. At year 2, we have 3307.5. So this one would be 3307. It's probably about here somewhere, just roughly. At year 3, we have 3472, which is probably about here. And then at year 4, we have 3646. So that's probably about, I'm going to say here. Now, notice how when you actually compare them together, okay, so notice how when you compare it together, instead of it actually going straight, it's starting to curve upwards. Although my line looks like it's straight, it's not. It'll curve upwards because, again, it's compound interest because it's adding a different amount each time. And you can see the difference between them. Okay, the amount of interest adding each year is more than if it was compound, simple. So here's a question, guys. Which one, if you actually wanted to gain more money, which which one would be better for you? Is simple or compound?
Compound.
Why compound?
You get more money.
Because you get more money in the end. Good. But it does depend on the interest rate as well. Alright, so let's go and relate this back to our geometrics. So if you wanted to find the common ratio for this, so we're now at the next page, guys, which is page 43. We need to find the common ratio for this. Anyone remember the formula for ratio? If common difference was any term minus previous. Estevan, what's common ratio? Is it? So if common difference was any term minus the previous, what would the common ratio be? Any term? No. Divide. Good. So if you want to find the common ratio between this and this, so remember common ratio is what you're multiplying by. All you do is get any term divided by the previous. So in this case, it's 3150 divided by 3000. Okay, 3150 divided by 3000. So the common ratio is 1.05. Okay, so to get the next term, you're just multiplying by 1.05. That's easy. Everyone knows this. And you know what this is as well, guys? This is also the interest rate, but maybe that'll confuse you a bit. So let's keep going. So from that, we need to learn how to write a recurrence relation, which you guys already know what that is. So you're telling me two things. What's the starting term or the beginning, and then what's the common ratio? Okay, those are two things for any question you get. That's all you need to tell me. Okay, so let's do this one here. We're at page 88 now. So let's do this. Let's make a recurrence relation for this. All right, thank you, Samuel. You tell me in this example, reading the question, what is my starting amount? Good. So we write for our A, 10,000. Okay. Common ratio. How do we find the common ratio? Now this is a bit tricky.
Isn't it 1.075?
We could do that, but we need to calculate it. Okay, so do you guys remember the two common ratios that we learnt about? One's increasing, one's decreasing.
This one's increasing.
If it's increasing, it's going to be 1 plus percentage over 100. And if it's decreasing,
It's 1 minus.
1 minus percentage over 100. Okay. So in this question, is it increasing or decreasing? Read the question. It's most likely increasing. Okay, this one. He's not paying them back, yeah? He's investing money. So, in this regard, it's going to be increasing. So we're going to use 1 plus percentage over 100. What's the percentage here, guys? Look at the question. 7.5. So plus 7.5 over 100. So just put that in your calculator.
Oh, 1.075.
1 plus 7.5 over 100. 1.075. So therefore, if you put all this together in our recurrence relation, my starting amount is 10,000. And to get the next number, I am multiplying by 1.075. That's it. Easy. That's all you need to do for recurrence relations. And so, Attila, if I was to ask you, how do I get the next three terms? What am I doing? You start at?
Start at 1.0. No, you start at 10,000.
And then, what are you doing each time to get the next number?
Times it by 1.
Just times it by 1.075 each time. That's it. Okay, so here, let's put it to practice. T1 is going to be whatever you had at the beginning, which is 10,000, as Attila mentioned, and then you're just multiplying by 1.075. So let's put that in. I'll do it on a calculator as well, short way. So 10,000, and then you press enter, and then you press times whatever your common ratio is. So every time you press enter, it's going to give you the next term. So that one's 10,750. So that means to get the next number here, you have to multiply this by 1.075. Okay, so again, press enter. It's going to be 1156.25. Okay, 1156.25. Wait, oops, sorry.
Oh, we missed them. How much cents are
Yeah,
in a penny?
actually don't know. 11,556.25. Sorry. 556.25. So sorry. And then again, repeating the process. Oh, sorry. 11,556.25. Okay, and then if you repeat that process, we've got 12,422.97. Okay, so again, you just keep pressing enter to get this. So after 3 years, his balance will be 12,422.97. Yep, you round it because what do we have here? 96, yeah? So we'll make it 97. Any questions with that? That's not too hard, yeah? It's just compound interest again. You're just multiplying by the same number. All right. There's that one, and then there's this one, and then I think we've got a couple more examples, and that's it. All right. So I want you guys to try and do this one yourselves. Shh. All right. Shh. Thank you. All right. So let's do this together. In this question, this person's investing 1,500 at this rate for 6 years. Remember the two R's that you're using. If it's increasing, it's R equals 1 plus percentage over 100. And if it's decreasing, it's going to be 1 minus percentage over 100. So in this question, if you're investing money, where is it going? It's going to go up because it's going back to you. Yeah. So just keep that in mind. That means we're going to be using this formula here. All right. So the starting amount. Anyone want to tell me?
1,500.
Easy. All right. So let's start with that. That's 1.5. Because we know that this is the investment amount at the start. Cool. The value of R is, again, you have to determine if it's going up and down. Chris said it's going up, so we're going to go and use 1 plus percentage over 100. 1 plus 3.5.
No, I'm saying like the rules hold. They must be like.
Okay, so put in your calculator. 1 plus 3.5 over 100 equals 1.035. Alright, so putting all of that in your calculator, T0 is 1,500. Sorry, in your recurrence, 1,500, and you're multiplying by 1.035 each year to get the next number. Okay, that's it. Easy. Cool. Alright, now, next thing is, it's asking us how much money will this guy have after 6 years. So for this one, because it doesn't actually ask you to list every single one, you don't have to show all of this. Okay, you don't have to do that. But what would be a good idea is maybe to, at the very least, tell me the value of each one. So T0, T1, T2, or you can use Y1, Y2, doesn't matter. Term 3, term 4, term 5, and we're looking for term number 6 or year number 6, all the way up to there. So, using my calculator, I know that I'm starting at 1,500. Okay, press equals, and then we're going to go times 1.035. So remember, we started with, at the start, 1,500. Okay, easy. Next term is going to be 1,552.5. So, Why isn't it working? Okay, let me use another color, sorry. Term number 2 is 1606.84. Okay, term number 3 is 1663.08. Term number 4, okay, and just confirm me if I got it right or wrong, it's 1721.28. 28, sorry. And then term number 5 should be 1781.53. So in the end, after the 6th year, this guy should have 1843.88. So the total investment in the end is 1843.88. Easy. So if I was to ask you this, let's see if you can figure this out. Evangelica, can you tell me, after 6 years, how much interest did this guy gain? So how would you work that out if it asked you that? How much interest? Yeah, good. So you'd go T6, take away T0, yeah? Which should be 1843.88, take away 1,500. And that will tell you how much money he actually made. Okay, so just in case it asks you that, make sure you keep that in mind. So 343.88. Okay, that's if it asked you how much interest did he gain. So if I asked you, Tiller, how much money did he make? He made $343.88 in 6 years. All right. I'm going to stop there.